Okay, so number 6, Jamal makes $12 an hour mowing yards and $6 an hour raking leaves. He cannot work more than 15 hours per week. Write and graph the two inequalities that Jamal can use to determine how many hours he needs to work at each job if he wants to earn at least $120 per week. So we know this is an inequality because it says at least $120 and cannot work more than 15. Those are both things that make us think of inequality symbols, greater than, less than, etc. So let's start by writing the inequalities. We're going to start by defining our variables. So X, he makes $12 an hour mowing yards. Okay, well, if we're trying to figure out how many hours, that means X needs to be hours. And I'm going to say this is for mowing, hours mowing. Y, $6 an hour raking leaves, can be hours raking. Okay, well, the first limitation they give me is that he cannot work more than 15 hours. So if I just add the hours together, it needs to be less than or equal to 15. His mama does not want him to work more than 15 hours. Okay? Then the second thing they give us is that he wants to earn at least $120 per week. So if he earns 12 for every hour he mows, that's 12x, plus 6 for every hour he rakes, we want that to be at least 120. That means more or equal to 120. Okay? So let's go ahead and graph these. So I'm going to solve them for y, because that's the only way I can graph, is if they say y equals mx plus b. So the first one, I'm going to move the x over. So y is less than or equal to negative x plus 15. Second one's a little more complicated. I'm going to have to subtract the 12x, then divide by 6. So y is greater than or equal to negative 2x plus 20. Okay? So let's graph those two over here. So the first one, we have a y-intercept of 15 and a slope of just negative x. Okay, solid line because it can be equal to. You'll notice I'm not really going to go into the negatives because if this is representing hours, I'm not going to have negative hours. So I'm not even going to worry about this part. Okay, the other one, I'll change colors here. Y-intercept of 20, slope of negative 2 this time. Again, solid line. Okay, but I need to shade these. So going back to the first one, y is less than or equal to, right? So thinking about the green line, I want to go below the green line and shade. Again, I'm not really going to worry about the negatives because I can't have negative hours. But then thinking about the other line, the red one, y is supposed to be greater than or equal to. So I'm going to go above the red line. Okay, so looking to see where it has been double shaded, we've got this lovely little intersection down here. Okay, so going to answer their questions. If he decides to mow for 11 hours, well, that means that's an x value. What is the maximum number of hours he could rake? Okay, well, let me go on the x-axis to 11 hours mowed. Okay, that'd be right here. So if we want to know the maximum number of hours he could rake, well, I'm going to go up the graph to the maximum point that will work, which is this point. I read it across, and it's 4. Okay, so the maximum number of hours he could rake would be 4. Which makes sense, right? If he's only allowed to work for 15 hours, his mom was going to say, well, if you've already done 11, you can only do 4 more. Okay? Next question. If Jamal decides to rake for 6 hours, that's a y because it's raking. What's the minimum number of hours he would need to mow? Okay, so going to raking hours of 6. Okay, here's 6 right here. I'm going to go across the graph. Okay, I hit it right here. Or I could keep going and I hit it right here, right? Or anything in between. But they want to know what is the minimum number. Well, the smallest number that will work is this point right here, 7. Okay, that means 6 plus 7 is only 13 hours, so Mom was happy. He didn't work too much. But also, 6 times, how much does he get for raking? 6 plus 7 times 12 is going to give him at least $120, the money that he wants. 36 plus 84 gives us exactly 120. Okay, so that's the minimum number of hours that he would need to work. He could work more, according to Mama, but he doesn't need to because he's made $120 at that point. Okay? All right, Number 7, this is very similar to what you would see on a test or quiz. Prove that the ordered pair, negative 4, 2, is a solution to the system of inequalities by using 2 methods. Well, those 2 methods every time have to be graphing and plugging in. Every time. You don't have any other option, okay? So I'm going to start by graphing because they're already solved for y equals mx plus b, which is nice. So my first one, negative 5 halves x minus 2. So here's minus 2. Negative 5 halves would be here, and here, and here. Okay. It was less than or equal to, so I can draw a solid line. And less than would mean I shade below. Okay, next line. We've got less than negative 1/2 x plus 2. Plus 2 is right here. Negative 1/2 x. So I got a slope of negative 1/2. It's not equal to, so I have to draw dashed lines here. I believe it said less than. Am I correct? Yes, less than. So we're going to shade below the line. Okay, and we can see that double shaded region is right in here where it's this lovely bleh color. Okay, so to prove if negative 4, 2 is a solution, we just need to go graph it, right? So I'm going to go graph negative 4, 2, right there. Is it in the double shaded region? Yes, it is. So it is a solution, but they want us to prove it twice using the plugging in method and graphing. So now I'm going to go plug it in. So again, negative 4 is the x and 2 is the y. So for this first equation, that means I've got 2 is less than or equal to negative 5 halves times this negative 4 minus 2. So let's work this out. Negative 5 halves times negative 4. Remember, you do top times this. So 5 times negative 4 is negative 20. Divided by 2 is negative 10. But this was negative, so really it's positive 10. Minus 2. So 2 is less than or equal to 8. Well, yes, 2 is less than or equal to 8, so we're good there. Okay, let's do the bottom one. Again, I plug in x and y, so 2 is less than negative 1/2, negative 4 plus 2. Well, half of 4 is 2, and a negative times a negative is a positive. So 2 plus 2, and 2 is less than 4. So yes, so we've proved it in 2 different ways, graphing and plugging it in. All right, last one. You've hung in there for a long time. I appreciate it. So prove that the ordered pair is not a solution by using 2 methods. Well, again, those 2 methods are just graphing and plugging in. These are not solved for y equals mx plus b, so I'm going to just plug in first. I have to do both anyways, but it'll be easy to plug in when they're in standard form like this. So x plus y is supposed to be greater than 2. So x plus y is supposed to be greater than 2. Well, 1 plus negative 3 is negative 2. That is not greater than 2. Right off the bat, honestly, I don't have to do any more. It doesn't work for the first point, so it doesn't matter. It could work for the second point, and that'd be cool, but it doesn't matter because it doesn't work for the first one. So really my work is a little bit quicker there than I anticipated. Okay, but now I need to solve these for y equals mx plus b. So I'm just going to rewrite them over here. Here's the first one. Here's the second one. So the first one, I'm just going to move the x over. Second one, I'm going to subtract 2x, but then I also have to divide everything by negative 1, which means I'm going to have to flip my sign as well. So I'm going to have y, flipped sign, change the 2x, change the 1. If that was too fast for you, pause it, work it out, step by step. Make sure you get the same thing. All right, so now let's graph them. Y is greater than negative x plus 2. Here's my plus 2, slope of negative 1. Have to use a dotted line because it's not equal to. Okay, y is greater than, so I need to shade above the line. Okay, second line, y is less than 2x minus 1. Positive 2 is my slope. Again, a dotted line. This one, y is less than, so I'm going to shade down the y-axis below that line. And I see my double shaded region, this lovely black color right here. Alrighty, so again, I'm trying to prove if 1, -3 is a solution or is not. So 1, -3, it is not in the double shaded region, so no, not a solution. Okay, so major lessons to learn here. You can solve a system of linear inequalities. You just have to do it with graphing and looking for the double shaded region, or by plugging in points. Okay, also remember that there's an infinite number of solutions because there's an infinite number of solutions because there's an infinite number of points in that double shaded region. But that does not mean that your answer is infinite solutions every time. Your answer is really shown on the graph by looking at that double shaded region. Okay, so if I ever say solve, I mean put it on a graph and show me where that double shaded region is in here. Alrighty, so you should have practice that is in Schoology that you can put Notability and work through. Make sure